Hey, what's up guys, it's Tekosaur. It's been about 6 months since I uploaded the Intel 14700K undervolting and optimization guide, first in BIOS and later on by using Intel XTU Windows software. But then a lot has changed with the controversial issues surrounding Intel latest CPUs. Many users are complaining about instability and bad experience, but we now have Intel recommended settings for motherboard vendors. And upon some requests, I think it's worth checking what ASRock has done to follow Intel guideline. They have released a new BIOS update just about 10 days ago, indicating in the notes here that they have optimized profiles as per Intel recommended guidelines. So all of that makes it the perfect time to make this recent, fresh follow-up video. I would like to note that even if you are not using this specific Z790PG SONIC motherboard by ASRock, you will find that most of those things I'm about to show are quite familiar, as well as if you are using one from a different brand such as ASUS, MSI, or Gigabyte AORUS. So here I am installing the new BIOS on my motherboard. Here we are on version 12.6. By default, it will start with this simple dashboard. But by clicking F6, it will take us to the advanced mode. Then in the OCT Weaker tab, we'll find the new option that wasn't present before this update, which is the power delivery profile. We have 3 options to choose from: BIOS default, performance mode, and baseline mode. As we go on, we are going to see the vast difference between them. But before doing so, I want to refer to Intel's official recommended schema so we can learn first what those values mean. Intel gave motherboard vendors some recommendation, with first being the current excursion protection or CEP to be enabled. This option is designed to prevent system instability caused by insufficient CPU voltage under certain scenarios. If the processor is drawing too much power for the current load, it lowers the power draw, so it will be useful to improve stability and protect the CPU over the long run. Second we have is the Enhanced Thermal Velocity Boost, or ETVP for short. Also this one should be enabled, which will keep the clock ratio when a certain temperature is reached in order to lower the temperature of the CPU. It works along with TVP and TVP voltage optimization all together, and they should all be enabled. Third we have is the ICC Max Unlimited Peak to be disabled, which means that the CPU can't draw unlimited amperes. Instead, it should be defined to a specific value depending on the profile and not exceed a maximum of 307 amps for the worst case scenario in case of the 14700K CPU. Then we have the TJ Max offset to 0. That simply means that the maximum temperature allowed should be kept at the default one set by Intel and not shifted by any offset. Also they indicate having all C states to be enabled, including the C1E. This way it will make the CPU save on power and give the CPU some relief to cool itself down when it's not requested to work hardly. Finally, the AC and DC load line. The AC load line adjusts the core requested voltage or VAD, and a lower AC load line value results in a higher VAD, and while a lower AC load line helps maintain stable voltage during transient loads. As for the DC load line, it's used for power draw calculations done by the CPU. It determines a steady-state voltage drop under continuous load, and a lower DC load line reduces the voltage drop, ensuring stable operation and efficient power usage. So in the end, balancing AC and DC load lines plays a crucial role for optimal CPU performance and stability, in particular when overclocking and undervolting. Here Intel doesn't specify a value for the AC, but they say it shouldn't exceed the 1.1 value, and the DC should match it as well. Lower values are possible to use if they match the board design and voltage regulator capabilities. In the next section, Intel specifies some CPUs models and their profiles. For the 13700 and 14700K, we have baseline and performance profiles. For ICC Max, we have 249 amps for baseline and 307 for performance. Then we have PL1 with 125 watt for baseline and 253 watt for performance. As for PL2, 188 watt for baseline and again 253 watt for performance. And in the notes they say it's what recommended for optimal performance. But they also say here in the notes that Intel does not recommend the baseline power delivery profiles for the 13 and 14 Gen K processors unless required for compatibility. Though this would greatly depend on your cooling setup, so your CPU cooler may handle more than those power limits or may not. Let's go back to our BIOS. I'm still on the BIOS default power profile with all default settings. Here in the CPU configuration, all is set to auto, and checking the TVP information, we can see that for the BIOS default profile, we have some defined ratio clipping. Once the temp has reached 70 degrees in any active core, like when one of the cores is active and reaches 70, it will clip its ratio from 56 to 55, reducing the clock ratio by 1. Once more than 2 cores are active, it will clip further to 54 as shown here. Then when it reaches 100 degrees Celsius, it will further clip it for 2 more ratios, reaching 53 when 2 cores are active and 52 when more than that. Out with TVP and checking the CPU core current limit, the ICC max, by default it's set to auto and you can see the value is 307 amps. That aligns with Intel recommendation for the 14700K as we saw for performance profile up to 307 amps. So with the default price profile, you can expect it to lean more toward performance rather than baseline column. If you decide, you can also remove the limit by changing the limit from auto to enabled like so, which would remove the current limit, but keep in mind that Intel doesn't recommend doing that, so it's better to keep it on the defined auto. Down here we also see the IA and GT CEP, which are the current excursion protection, with the IA being for the cores and GT for the iGPU. By default it's set to auto, and in that way I don't know whether it's enabled or disabled, so to make sure you can set them both to enabled. Exiting CPU configuration, let's head to the voltages menu and see what they have set in here. We can see that for CPU load line calibration or LLC, they have explicitly set it on level 3. This will surely be different based on motherboard voltage regulator design and the way in which motherboard vendors choose the leveling scheme. But in my case, I have 5 levels. The 3.5 is a new addition in this BIOS update. And basically, level 1 gives the least amount of voltage drop under a higher CPU load line, which would render a better stability outcome and a consistent clock ratio. However, the trade-off is higher temperatures, which is why they made those levels in order to hit your stability target under the least amount of extra generated heat. In my test and optimization guides, I always opted for level 3 as it gave me the stability I want with the least amount of heat generated. It's a middle way, and here also in the BIOS default power profile, they choose it like so. So on auto, it's going to be level 3 for this profile. Going down here, we can see the IA, AC, and DC. As Intel said in the recommendation document, they shouldn't exceed the 1.1 value, and here in fact they don't. Also they should match, and they do. So in terms of VR configurations, it's all aligning well with the Intel provided document. So things are going well so far. Now that we covered every part of Intel guideline with the first profile, let's head on to the next one, that is the performance mode. But the first thing that we can notice that there is no TVP information shown in here. Therefore, it's been switched off for this one. And going down, we can see that the ICC max is actually set to 512 amps, which is a maximum value allowed on this motherboard. If we remember, Intel told us to not exceed 307. This profile instead went above and beyond that with 512 amps. So from what I can tell, this profile is not following 2 of the specified rules by Intel until now. Going to the voltages section, in the load line calibration, we can see that this time it's been set to level 4 instead of the level 3 like the BIOS default profile, which in my humble experience will give a less stable system, especially under load. I never advise setting LLC higher than level 3 to avoid any stability issues. And to make things worse, going to the IA and DC load lines, we can see that while they don't exceed the 1.1 limit, they still don't match as per Intel recommendation, with the AC being relatively lower than the DC. So based on what I can tell, the performance mode power delivery profile is unadvisable to use for ASRock, like this one, especially in the current way it's programmed. There is so much misalignment with what Intel has specified over and over. Finally, let's try on the baseline mode profile and see what we got. To make it short, in terms of TVP info, it's set in the same manner as the BIOS default, along with the ICC max at 307 amps, and the IA GT CEP is set to auto. But the difference here is found exclusively in the voltage settings. This time the load line calibration is set to level 4, and the IA, AC, and DC are both set at the limit 1.1. But hey, they match at least. So we can see that ASRock made a combination of settings across those power delivery profiles, and we are going to find out which is the best option to go with soon enough. But before that, I want to note to some other features worth knowing of as well. In the OCT Tweaker tab, there is this one called vCore compensation. In here, we can select different levels from 1 to 10. This will make the base CPU voltage higher, which will improve stability, but naturally will also increase the generated heat. Here, as said by ASRock, it's advisable to use for CPUs with poor silicon quality. I usually keep it on auto, which is the default option. Next, we have the CPU cooler type. Here you can specify your cooler type between an air cooler or a liquid cooler from a range of 120 to 420 mm radiator size. And depending on what you choose, it will configure the PL1 and PL2 accordingly. So with an air cooler, PL1 will be set to 125 watt, while a liquid cooler at first level to 180 watt, second level to 241 watt, and finally from a 360 mm to 420 mm, it's going to be 265 watt. In my current rig, I'm using an AK Nucleus 240 mm AIO liquid cooler. And I must say this cooler is actually so good that I can safely put it in the third liquid cooler category and never worry. And especially since I undervolt, therefore it will not hit that high power consumption under all loads I tried. The reason I keep it this way, so I don't get capped by a lack of power. You can of course define it based on your cooling setup. Anyway, a few BIOS versions ago, ASRock introduced a new feature called CPU Indicator, which measures the CPU silicon quality and gives us the core speed for both P and E cores, as well as their quality and overall CPU quality. My CPU is a bit above the average, being at 85, and almost hitting the top 10%, but still far from the top 1%. The weird thing is that initially when I got the CPU on release, the CPU indicator gave me a lower score, as you can see here being at 73. It was actually really disappointing for me to know that. Maybe it was a miscalculation by ASRock, and in a later BIOS version update, they adjusted it for the 14th gen. But anyway, you can use it to understand your CPU weight and CPU silicon quality. Another new addition I found in this BIOS version is the addition for the new level for the load line calibration. We now have a 3.5 level, which comes in between level 3 and level 4. And this is definitely interesting to experiment on. As previously said, my system was unstable with level 4 after undervolting, but stable with level 3. I will be interested to try it on a 3.5 level to see if we can get it stable with my undervolting settings plus the lower LLC level that will translate to lower temp under load. I will do my best to try it on as soon as possible and share the findings with you guys in a specific video, so don't miss out on that one. Now before proceeding to testing, it's worth noting that I had to change some settings such as disabling the undervolt protection in order to enable our XTU profile later on for some tests, and I activated the XMP profile. I also made sure to enable all of the C states as Intel has indicated us to do, and again turned off the Intel virtualization technology and VTD to enable undervolting in XTU later on. Finally, I tuned my fans to performance mode. Other than that, I kept all to auto. So I'm going to call this one the default profile and save it in here. And here you can see all the changes I've done versus what the BIOS default had. Alright, now it's time to test the power delivery profiles in action. Let's go for it. In Cinebench R23 multi-core test, we've got 33,990 on BIOS default, 35,329 on performance mode, and 33,883 on the baseline mode. So while the performance mode doesn't go hand in hand with the Intel recommended guidelines, it still managed to hit the highest score. Let's check the secret behind this. In XTU, as we run the benchmark, you can see on the dashboard here how the clock ratio is hovering around 5.08 GHz on P core and 4.07 GHz for E core, with the BIOS default profile. Package TDP at 253 watt, but still we are getting limited by power, which means the CPU wants more power delivered, but we are limiting it to 253 watt. But the package temperature is in a good range. Now with the performance power profile, we can immediately see some difference. It's able to push the P core ratio to 5.3 GHz and for the E core 4.2 GHz, with still the same power draw. The reason for that is the IA, AC and DC combo. That profile, it's making it reduce the weight, so in that way, it's requesting less voltage for a given ratio, allowing it to push a bit further than the IA DC combo on the BIOS default profile. Also surprisingly, having LLC to level 4 is able to make it run stable as the same power draw with good temps. So while it's a good customized profile by ASRock, but still it's not aligning with Intel baseline document. Finally, checking the baseline mode profile, we can see in terms of ratio and even scores we have seen, it's identical to the BIOS default one. I haven't noticed any certain observations with this one. And here we have the three profiles on the left hand side, and we are going to measure the maximum reached value for the following metrics. Core weight, which is a requested voltage by CPU, and we see it somehow high across the board, especially with the baseline mode. This to be expected with the variation of the IA setting, but at the end, that's only the requested voltage. The actual one by the voltage regulator is 1.48 for BIOS default, 1.384 for performance, and 1.512 for baseline being again the highest one. The uncore voltage is about 1.3 for all setups. Switching to the P-Core's clock, including the two fastest ones, in all three setups they have reached 5.6 GHz. And the same goes with the rest of the P-Cores, peaking at 5.5 GHz, and as for the E-Cores, at 4.3 GHz. As for temps, they are all well under control. And for the voltage regulator current, they are all in line with Intel guidelines not exceeding 307 amps. Power consumption is the same for all. Now we can switch gears and try those profiles, but this time with undervolting tuning we have done previously in this video recommended in here. It's exactly the same profile I'm using now. So now what we are about to do is try and get out along with those new power profiles to see the potential of mixing them with some undervolting. Alright, with that being said, let's go for it. As shown here, when I try to use the performance mode power profile with my undervolting settings, even if they don't change the IA DC load line, it's not working out at all. As you can see, as soon as I start the test, it will give an error or reboot by itself or give me the blue screen of death. I even tried the XTU stability test and it fails as soon as I press the start button. Instead, for the case of the BIOS default profile and the baseline one, it's working like a charm with our customized settings in BIOS. We'll explore the reason behind this, but before that, let's check the scores we got. For the two of them, we got pretty much identical scores of over 36,000 points, and that match quite well with our past scores after undervolting. So we are not losing any performance in here. Even when we start the test and check in XTU, we now see P-Core ratio at 5.5 while E-Core at 4.3. And they are running consistently like this throughout the test without dropping in ratio. So overall we see an increase in the scores along with a higher and more consistent clock ratio while maintaining good temp for both the BIOS default profile and the baseline mode. Now let's head back and experiment with the reason behind the performance mode failing in our test. I believe it could have to do with the way the IA and DC are placed and the load line calibration set to level 4. We remember from previous experience that on level 4, it's usually quite unlikely to be stable, but then you see the default BIOS power profile has set it on level 3 while baseline on level 4. But the difference here again between all of them is the IA and DC load line. So that could be a reason behind such a behavior. Checking some metrics this time with the power delivery profile, here the performance mode failed the test, therefore it's not available. So this time our voltages has went down slightly. For weight we got 1.334 volt for BIOS default, and for the baseline mode 1.378. We also see this time that our uncore voltage has went down by a whole 0.1 in comparison to prior undervolting. And all of our P-cores has peaked at 5.6 GHz while keeping our temps in check, and the same goes for the power current, peaking at 209 amps for BIOS default and 215 amps with baseline. Finally, our power consumption is also within the range. Let's now try out those power delivery modes, but this time without much tinkering in BIOS, and instead do the undervolting and tuning on XTU software by using the same profile from this video guide here. You guys remember, this is the same profile I shared with you the last time. The only thing to do is changing the ICC max from default unlimited to whatever Intel has defined in the guidelines. For the 14700K from 249 amps and up to 307. I'll hit the apply and override the profile with the ICC max change we have just done. And again with both BIOS default profile and the baseline mode, it's working like silky smooth, but the performance mode is giving us a hard time yet again. Probably for similar reasons as with the BIOS modified undervolting settings we tried before. As for the scores, they align pretty well with the previous ones at 36,000 points. Checking them this time with the XTU profile also seems again the performance mode failed this test, so it's not there. But we see our BIOS default profile rate has significantly been lowered to around 1.284 volt. As for the baseline mode, it's still around 1.35 volt. It's a remarkable difference in this XTU setup if you remember that we focused on setting the 2 bus cores clock to 5.8 GHz, since those 2 cores usually require less voltage to run a specific ratio, and this may help in single workloads. You can see they reach max of 5.8 GHz with the rest of B cores at 5.5. As for the E cores, we also increase the clock ratio to 4.4. Terms are quite the same goes for VR current and for consumption. Now I need to point out to something pretty important. When I choose performance or baseline power delivery profiles and try to change the load line calibration level to anything other than the predefined one, it wouldn't change. So for example, if I go ahead and change it to level 3 and save it changes and all, as you can see, it's still back on level 4. And I found that it's exactly the same case with the baseline mode profile. Only the BIOS default profile allows you to change the load line calibration level freely. Therefore, please don't expect that all your changes are to be applied when using those 2 new profiles. Checking in XTU, the interesting fact that when I use the XTU profile along with both the baseline and the BIOS default profiles, we are no longer getting the indications that we are limited by power while running the test. And we are not exceeding the 90C temp as well. So in conclusion, ASRock has made some efforts in making sure to follow Intel guidelines by making those power delivery profiles. While the performance one isn't strictly following them and it didn't work quite well with us, but I will personally choose the BIOS default one plus the undervolting changes we have made previously. And so we have arrived to the end of this video. I really hope it was useful, and honestly speaking, I wish I could try out more boards from different manufacturers such as ASUS, MSI, AORUS, etc. So in this way we can experiment and see what each of them has provided for their users after Intel has released their guideline recommendation settings. But logically that will be more likely to happen if the channel gets your support in order to have more access to different parts. So I ask you kindly, if you like my content and really would love to see more stuff of this kind, please support the channel in any possible way. Of course, also by simply liking this video and subscribing to the channel, that will be quite helpful in the long run. I would like to take this moment and share with you all that whenever I see someone having their system working top-notch after following those guides or learning how to do it themselves, I feel so satisfied and glad for them, because I can understand the frustration of having a bad experience with your PC when you paid dear money for it. I hope that with this video along with the previous ones were of help to understand what those settings mean and how they may influence the performance, stability, and just about everything. At the end, I want to thank you for tuning in. Again, if you have any question, please don't hesitate to drop a comment or join the TechOSor Discord server for any support. Thanks for watching and see you in the next one.